which is bigger, e to the power of pi or pi to the power of e? You are not allowed to use a calculator. I'm going to prove this problem in 3 lines. Here's a challenge. When you see e to the power of pi and pi to the power of e, well, both of these are insane transcendental numbers raised to transcendental powers. There is absolutely no obvious reason why we should be able to compare them, but here's a trick, and it's beautiful. We are going to define one function and study it completely. First of all, we can write f of x is equal to x to the power of 1 over x, and for all positive x. This is the function that asks, what is x raised to the power of 1 over x? We want to find where this function is maximized. To do that, we can take its derivative. We can differentiate, taking the natural log of both sides. So we have ln of f of x is equal to ln x over x. And then the reason for this is because once you take the ln, it will become ln of x to the power 1 over x. By the property of natural logarithms, we can bring the exponent outside to be the coefficient multiplied by ln x. So just ln x divided by x. Now we can differentiate both sides implicitly with respect to x. So f prime of x divided by f of x is equal to 1 over x times x minus ln x times 1 divided by x squared. And this will equal to 1 minus ln x divided by x squared. So f prime of x is equal to x to the power of 1 over x times 1 minus ln x divided by x squared. Now, since x to the power of 1 over x is always positive and x squared is always positive, the sign of f prime of x is entirely controlled by the numerator 1 minus ln x. So then, we know that f prime of x, we want to be greater than 0, which will mean that 1 minus ln x is greater than 0, or ln x is less than 1. So it would mean that x is less than e. So then, f prime of x is equal to 0. Meaning that x is equal to e. And then f prime of x is less than 0. Will give us x is greater than e. This tells us that f is strictly increasing up to x equals to e, and strictly decreasing after x equals to e. In other words, x equals to e is a unique global maximum of f. So then, we can get that f of e is equal to e to the power of 1 over e. And this is going to be our global maximum. Now, here's where everything comes together. Since pi is greater than e and f is strictly decreasing for x is greater than e, we can get that here. F of pi is less than f of e. And we can substitute, and we can get that pi to the power of 1 over pi is less than e to the power of 1 over e. Now we can raise both sides to the power of e pi, which is positive. So the inequality is preserved. So we'll have pi to the power of 1 over pi to the power of e pi is less than e to the power of 1 over e to the power of e pi. So then we'll have pi over e, pi to the power of e is less than e to the power of pi. So the result is e to the power of pi is going to be greater than pi to the power of e. So that is how you solve this problem. Like and subscribe if you like this kind of Olympiad style problem.